Imagine standing beneath a clear night sky, one so pristine that every star seems sharp enough to cut through the darkness. Now imagine that among those countless points of light, there was once a single star, so brilliant it outshone, even Venus casting its glow with such intensity that it could be seen by anyone who dared look up. Ancient sky watchers saw it, documented it, gave it a place in their celestial maps. They may have whispered about it over campfires or etched its position into parchment and stone. And then, without warning, it was gone. No gradual dimming, no fading over decades as stellar embers cool. Just gone as if the heavens had decided to erase it. Look for it now, and you'll find nothing but a patch of unremarkable darkness, a void where something magnificent once lived. Modern telescopes, far more powerful than anything those early observers could have imagined, sweep over the coordinates where the star should be. But the space is empty. Instruments designed to detect even the faintest glimmers of ancient galaxies return nothing but silence. It's the kind of absence that nags at the human mind. We can explain a star's life cycle, in meticulous detail how it forms from collapsing clouds of gas, how it burns for millions or billions of years, and how it eventually dies, sometimes in a cataclysmic explosion, sometimes in quiet retreat. But here is a puzzle that doesn't fit the script. A star bright enough to etch itself into human memory should not be able to vanish without leaving so much as a trace of its remains. Yet every scrap of modern evidence suggests that's exactly what happened. The ancient records are tantalizing. Some come from meticulous astronomers, others from sailors who navigated by the night sky, and others still from poets who simply wrote about what they saw. Their accounts may differ in style, but they converge on one fact: there was a star here, and now there is not. We can trust that people in the past were capable of making mistakes, yes, but were all of them mistaken? Across different continents, cultures, and centuries, could so many independent eyes have been fooled by the same illusion? This is where the mind starts to wander. You might find yourself glancing at the sky, trying to imagine a light so vivid it could cut through the haze of history, only to be plucked away by forces we can't yet name. Was it the death of a star in some silent, extraordinary way, a kind of cosmic vanishing act? Or was it never there at all, merely a shared mirage stitched into the fabric of human perception? And if it was real, if it truly existed, then the question becomes even more unsettling. Stars do not just switch off. They are bound by the laws of physics, and those laws leave fingerprints. A supernova leaves behind a glowing remnant, a neutron star or a black hole. Even the slow fading of a star into a white dwarf leaves a faint ember that our telescopes could find. This disappearance is like closing a book and finding that the final chapter has been torn out. Some astronomers treat it as an anomaly that will eventually yield to patient study. Others admit quietly that they are not so sure. An absence this perfect, this complete, doesn't feel like something we can easily file away in a catalogue of known stellar behavior. It feels different, as if the universe is reminding us that it still holds secrets, and that sometimes those secrets come not in the form of things we see, but in the spaces where something should be. If you let your imagination run with it, the possibilities become almost dizzying. Perhaps it was a star pulled into the darkness of a black hole so swiftly that the light we once saw was merely its last cry, a message from a past already swallowed whole. Or maybe it was a flare from some distant cosmic event, a light that passed through our sky only briefly before continuing on its journey elsewhere. The universe is vast, and light is a traveler with no regard for our sense of permanence. Still, the thought lingers. What if it comes back? What if one night, when you're least expecting it, you look up and find that bright, impossible star shining again in the place where it once lived? Would you rush to tell someone, or stand frozen, afraid that even acknowledging it might make it vanish once more? And if that moment came, would you place your faith in science to explain it, or allow yourself to believe just for an instant that you'd witnessed something beyond explanation? For now, all we have is the emptiness and the stories of those who swear they saw it. Somewhere between the ink on ancient charts and the silent expanse of modern astronomy lies a mystery Whether it's the ghost of a star, a trick of the light, or something else entirely, its absence speaks loudly. It tells us that the sky is not as fixed as we think, that even the brightest lights can be lost, and that sometimes the most haunting thing of all is not what we can see, but what we can no longer find. Have you ever considered that a map might be hiding something from you, not out of error but by design? The earliest star maps were more than navigational aids. They were acts of preservation, an attempt to hold on to something that seemed unchanging, eternal. To chart the sky was to make a claim against time itself, to say this is how it is and how it will remain. But a map is never the whole truth. It is always a distillation shaped by the choices of the person who draws it. Every dot placed on parchment is an act of inclusion, and every omission is just as deliberate, even if it happens without conscious intent. Imagine a scribe in ancient Babylon, leaning over a clay tablet, lit only by oil lamp, pressing tiny impressions into the surface to capture the positions of stars. Each mark is a decision. Which stars matter enough to record, which are too faint, too fleeting, or too unimportant to carve into the record. The act of mapping the heavens was not just science, it was storytelling. And like any story, it could be edited. Some stars were given pride of place, depicted larger, brighter, more central. Others, for reasons lost to time, were left out entirely. And then there are those that appeared once, perhaps noted in the margins, then vanished from later editions as though they were never there at all. When you unroll an ancient chart of the sky, you are not looking at the heavens as they truly were. You are looking at a version of them filtered through the eyes, culture, and priorities of its maker. A map can tell you what its creator saw, but also what they chose not to see, or what they decided you did not need to know. It is an artifact of perspective, shaped as much by absence as by presence. And in those absences you may find the first whispers of a deeper mystery. Consider the constellation of Orion. Today we recognize its shape instantly, but the exact stars that make up Orion have not always been agreed upon. Some maps from antiquity depict extra points of light within its belt and shoulders, stars that have no place in modern astronomy. Were these mistakes, exaggerations, or genuine observations of stars that no longer exist? The answer might lie in the spaces between the known, in the quiet gaps that no one bothers to question because they have been missing for so long that their absence feels natural. It is tempting to think of these omissions as accidents, but history suggests otherwise. Maps, whether of the earth or the sky, have always been political in their own way. To choose what to include is to declare what matters, and sometimes what matters is to hide. A star that appears only briefly may be considered irrelevant, a curiosity at best, and quietly removed to maintain the illusion of stability. After all, the promise of a star map is that the stars will still be there tomorrow, next year, 1,000 years from now. Admitting that the sky can change suddenly, dramatically, would be to undermine that promise. Now imagine holding two maps of the same region of sky created centuries apart. Most of the stars match perfectly, but here and there you notice discrepancies. A bright star on the earlier map has no counterpart on the later one. At first you assume this is an error, but then you notice another, and another. The pattern emerges slowly, as though the sky itself is erasing parts of its own history. You might feel a shiver at the realization you are seeing not just a chart, but a record of loss. And loss is not always accidental. In some cases, a missing star might reflect a decision to align a map with prevailing beliefs or cosmologies. If a certain light in the sky did not fit the accepted order of the universe, it might be easier to remove it than to explain it. Ancient astronomers were not immune to the pressures of tradition, religion, or patronage. A ruler commissioning a star map might not welcome the inclusion of something that contradicted established doctrine. The safest choice would be to omit the anomaly, letting it fade from memory. Even in our own time, with satellites and digital sky surveys, we create curated versions of the cosmos. Astronomical catalogues omit data deemed unreliable, confusing, or irrelevant to the purpose at hand. Images are processed, artifacts are removed, and noisy signals are discarded. In a way, we are still making star maps the same way our ancestors did, highlighting what we think is important and allowing the rest to slip quietly into obscurity. The difference is that now we can erase things with far greater precision, leaving no trace at all for the casual observer. When you gaze at a modern star map glowing on your screen or printed in a glossy atlas, it feels definitive, like a statement of fact, yet it is still a crafted thing shaped by choices. It tells you what is there, but also silently decides what is not worth showing. And in the case of our missing ghost star, that silence is deafening. It appears in some ancient maps, absent in others, and nowhere to be found in the vast databases of contemporary astronomy. Its absence is so complete that if you did not know to look for it, you would never suspect it had been there at all. There is a strange power in this kind of omission. A missing star becomes a kind of shadow, a hole in the fabric of our understanding. The human mind does not like gaps. We are driven to fill them, to imagine what might be missing. In that way, a blank spot on a star map can be as compelling as the most brilliantly drawn constellation. It invites questions, speculation, even obsession. What was there? Why was it removed? And what does it mean that no one thought to tell us? If you think about it long enough, you begin to see the maps themselves not as static records, but as living artifacts constantly revised by those who hold the pen. Each edition is an act of rewriting reality, subtly altering our relationship to the sky. And if something as constant as the heavens can be edited, then perhaps nothing we take for granted is truly fixed. The ghost star's absence on modern maps is not just a void in the sky, it is a void in our collective memory, engineered or accidental, we cannot yet say. But what is certain is that someone at some point looked at a bright light in the heavens and decided it would not survive the next draft. And that choice, preserved across time, may be the reason we are left chasing whispers instead of studying facts. One day you might find yourself looking at a star chart and wondering not about the dots that are there, but about the ones that should be. And when you do remember this, the truth of the sky is not just in what is drawn, but in what has been quietly left out, perhaps forever. The history of astronomy is not just a record of what we have seen, but also a quiet archive of what we have lost. Across centuries and continents, from the careful scribes of ancient China to the meticulous scholars of the Arab world, observers have noted strange visitors in the night sky. They called them guest stars. Sudden bursts of light that appeared where no star had been before, lingered for days or months, and then faded into nothingness. Some of these guests left behind physical remains, expanding clouds of gas we now recognize as supernova remnants. Others, however, departed without so much as a footprint, leaving us only with ink on paper and the uneasy feeling that perhaps they were never really there at all. One of the most famous guest stars was recorded in the summer of 1054. Across the globe, it appeared as if the heavens themselves had been pierced by a burning spear. In the east, Chinese court astronomers noted its position near the constellation Taurus and tracked its brightness for nearly 2 years. In the Islamic world, scholars described it in detailed poetic language. In the Americas, the ancestral Puebloans may have etched it into rock art, a bright star beside the crescent moon. For a time it was so luminous that it could be seen in the daytime sky, an unblinking eye staring down at the Earth. Today we can point to the Crab Nebula and say that is what remains of the supernova of 1054. The story feels complete because there is a physical remnant, a piece of cosmic evidence we can measure and verify. But not all guest stars leave us this luxury. In fact, many disappear without leaving any trace we can detect with our most advanced instruments. The historical records of East Asia contain dozens of mentions of such transient lights, broom stars, sparkling stars, stars that came and went. In medieval Europe, there are scattered notes of bright points appearing in constellations where no such stars exist today. In the Middle East, manuscripts speak of sudden heavenly fires that burned out as quickly as they came. For every event like the Crab Nebula, there are many more for which we have nothing but words. Imagine reading one of these accounts. On the 3rd day of the 5th month, a star appeared in the south brighter than Venus. It remained for 40 days, then vanished. You search the sky where it was said to have been, consult radio telescopes, infrared surveys, ultraviolet scans, but find nothing. No expanding gas cloud, no neutron star, no black hole, not even a dim remnant hiding in the background noise. The space is empty, as though the event had been a dream shared by an entire civilization. This absence forces an uncomfortable question. If a star can vanish completely, leaving no physical evidence, what does that say about its nature? Was it truly a star in the astrophysical sense, or something else, entirely a flare from an exotic object, a gravitational mirage, an event from another layer of reality, briefly intersecting with ours to make matters stranger? Some of these historical guest stars were recorded by multiple cultures, separated by great distances and with no means of communication. The alignment of their records suggests they were seeing the same thing, which makes it harder to dismiss them as mere hallucinations or observational errors. And yet, with nothing tangible to point to in the present day, modern science struggles to categorize these events. In the absence of evidence, the most conservative approach is to file them away as unconfirmed, a polite way of saying we do not know what to do with this. There is a particular discomfort in the idea of something that once shone brilliantly in the sky, something that entire cities might have gathered to watch simply ceasing to exist without a trace. Stars are supposed to be vast, enduring furnaces. They do not just wink out like candles. Even if they die, suddenly the violence of their death should echo for millennia in the form of debris, radiation, and gravitational ripples. A complete disappearance should be impossible, and yet the pages of history insist it has happened. One theory is that some of these vanishings were not stars at all, but cataclysmic events in our own solar system, such as cometary outbursts or planetary collisions. But comets, however, dramatic, follow predictable patterns. Many reappear, and their dust trails remain visible. The truly baffling guest stars are the ones that simply do not fit events that lasted too long to be meteors, too bright to be comets, and too sudden to be normal stellar behavior. Another possibility, more unsettling, is that some of these lights were the result of gravitational lensing, the bending of light from a distant source by a massive object passing in front of it. If the alignment is perfect, the source can flare into sudden brightness, then fade when the alignment breaks. This would explain the lack of physical remains, but it also means that what people saw was not happening anywhere near where they thought it was. They might have been witnessing the magnified death of a star millions of light years away, its ghostly light delayed and distorted by the curvature of space-time. And yet, even gravitational lensing feels like too neat an explanation for all cases. Some guest stars persisted for months or years, their brightness varying in ways that do not match known lensing events. Some were said to change color pulse or split into multiple lights before vanishing. These details passed down through handwritten notes and oral traditions resist easy categorization. The more one studies the historical record, the more it begins to feel like a catalogue of absences, a list of things we no longer have. Each missing star is a reminder that the universe we know is a filtered version of reality, one in which the most transient wonders may be the hardest to prove. There is a quiet tragedy in that the idea that some of the most extraordinary cosmic events might come and go without ever leaving enough evidence for future generations to believe they happened. It is here that the ghost star takes on its most haunting form. In the stories of guest stars that left nothing behind, we see a reflection of its mystery. Was it one of these, a bright, impossible flare that drew the gaze of countless watchers only to erase itself from the cosmos? Or was it something even stranger, an object that existed only briefly in our universe before retreating to somewhere or someone else? When you look back at the careful records of those ancient astronomers, you cannot help but feel a certain kinship. They too were trying to make sense of fleeting lights, scribbling down coordinates and descriptions in the hope that someone centuries later would understand. Perhaps they knew that the stars they saw might never be seen again. Perhaps that is why they wrote them down at all, not to prove they existed, but to ensure they would not be entirely forgotten. And yet here we are with the same unanswered questions they had, staring at the same empty patches of sky. The difference is that now we have far more tools to look for answers, but the stars in question are long gone, their light extinguished before our telescopes were ever built. We inherit the absence, but not the thing itself. So the next time you read about a bright star that once lit up the heavens but no longer exists, remember this: the history of astronomy is as much about what has vanished as about what remains. And somewhere in that history, perhaps hidden among the lost guest stars, may lie the truth about the ghost star missing from every map. Stars, for all their grandeur and seeming permanence, are not immortal. They live and die on timescales that often make human history look like the blink of an eye. Most end their lives in one of two familiar ways: in a violent supernova that scatters their outer layers across the cosmos, seeding the galaxy with heavy elements, or in a quiet fade into darkness as they cool into white dwarfs and over unimaginable spans of time slip into the invisible stillness of black dwarfs. Both fates take billions of years to unfold, far too long to explain the sudden vanishing of a star that human observers might notice over just a few centuries. For that, we must look toward rarer, stranger endings. Among the more unsettling possibilities is the phenomenon known as direct collapse. The idea that a massive star near the end of its life could bypass the brilliant death throes of a supernova entirely and instead fold in on itself, collapsing straight into a black hole. No cosmic fireworks, no blinding final act, just a star ceasing to shine as if a switch had been thrown. It is a theoretical ghosting of the universe. On the grandest scale, a vanishing so complete that the only sign it happened might be the sudden absence of light. Imagine such a star in its prime, a luminous giant visible from thousands of light years away, burning with the energy of millions of suns. It has been there for as long as your civilization has kept records. Your ancestors charted it, navigated by it, maybe even wove it into myths. It has always been there, a steady beacon in the night sky. Then one night, without warning, it is gone. The patch of sky where it lived is still black, still sprinkled with other stars, but the one you knew is missing. The next night, it is still missing. And the night after that, no flare, no fading, just absence. Astrophysicists have begun to hunt for evidence of such events. The idea first gained traction when surveys of the sky began comparing modern photographs to decades-old plates and noticing that some stars, particularly in distant galaxies, had simply disappeared. Not dimmed, not hidden behind dust, but gone entirely. The odds are vanishingly small. Most massive stars end in spectacular explosions, but given the number of stars in the observable universe, even rare events can happen more often than we might expect. The physics of direct collapse is as elegant as it is terrifying. A star of sufficient mass can no longer support itself against gravity once its nuclear fuel is exhausted. Normally, the core's collapse triggers a shockwave that blows off the outer layers in a blaze of energy, but in some cases the energy is swallowed instead of released. Gravity wins completely. The matter that made up the star's body falls inward faster than light can escape, and the event horizon of a black hole forms before the outer layers can react. The result: no explosion, no debris, just an invisible gravitational pit where a star once was. In principle, we could detect such an event by the sudden halt in light and the faint flicker of neutrinos, ghostly particles that pass through matter almost without interaction, or perhaps by a brief shiver in the fabric of space-time itself, a gravitational wave. But these signals are subtle, fleeting, and require us to be looking in exactly the right place at exactly the right time. In the days before sensitive neutrino detectors and gravitational wave observatories, a direct collapse could have happened in our own galaxy without anyone knowing. The star would vanish from view, and history would record only its absence. There is an almost poetic cruelty to this possibility. Supernovae at least announce themselves, broadcasting their death across the universe in a display so bright it can outshine entire galaxies. Direct collapse offers no such drama. It is the cosmic equivalent of someone leaving a crowded room without a word, the door swinging shut behind them in total silence. One moment they are there, the next they are not, and everyone else must puzzle over when and how they slipped away. What makes this particularly haunting is that a direct collapse does not erase the star's influence. The black hole that replaces it still exists, still warps space and time, still exerts the same gravitational pull on nearby objects. It is there but utterly invisible, unless something wanders too close and falls in. In that sense, the star has not truly gone. It has been transformed into something we cannot see, a presence defined entirely by its absence of light. For ancient skywatchers, of course, there was no way to know this. If the ghost star we seek was a victim of direct collapse, its disappearance would have been inscrutable. The star would have been there 1 year gone the next, and its vanishing would have joined the realm of omens and mysteries. Perhaps it would be seen as the death of a celestial deity, a sign of cosmic change, or the opening of a dark door in the heavens. Whatever the interpretation, the truth that the star had collapsed into a hole from which not even light could escape would have been far stranger than any myth. Modern astronomers face their own frustrations with this mystery. Even with powerful telescopes, confirming a direct collapse is difficult. You cannot see the black hole directly. You can only infer its presence from the absence of the star and the subtle gravitational effects it has on its surroundings. And because the disappearance happens without warning, there is rarely before data detailed enough to prove what happened. In most cases, all we can say is, here was a star, and now it is not. There is also the uncomfortable truth that if such events are possible, they may have happened more often than we realize. Our records of the night sky are not as complete as we like to think. Before the invention of photography, the stars were mapped by human eyes, which could miss or misplace details. Even now, we only photograph certain regions of the sky at certain times, meaning a star could vanish in an unmonitored patch, and we might not notice for decades. The universe does not operate on our schedule. So when we consider the ghost star, the one that appears in old maps but not in new ones, we cannot dismiss the idea that we are looking at the afterimage of a direct collapse. The star shone for untold millennia, its photons traveling across the gulfs of space to fall upon human eyes and be written down in careful ink. Then, at some moment between then and now, its core caved in on itself. Its light ceased and its final act played out unseen in the dark. To think that this might be the fate of the ghost star is to accept that some of the universe's most profound transformations happen in silence. There is no cosmic drum roll, no blaze of glory, only the sudden shift from something to nothing. In the space between two human generations, a star that outlived empires and continents could vanish utterly, leaving us to wonder whether it was ever truly there at all. And maybe that is why this idea lingers, because it forces us to face the possibility that the universe is not obliged to show us its endings. Some stories fade to black without telling us how they end. Some stars die without saying goodbye. And somewhere in that silence, perhaps, is the answer to why a bright point of light once marked on the maps of the ancients has slipped so completely from our skies. For as long as humans have gazed at the night sky, there has been a quiet assumption behind the patterns we trace in the darkness that the stars themselves are indifferent, beyond the reach of anything but the laws of physics. They live, they burn, they die, and they do so without concern for the creatures who watch them. But every so often, a mystery forces us to reconsider whether that assumption is safe. The ghost star, a bright point once recorded in careful astronomical charts, now gone without a trace, invites a more unsettling question. What if the universe's most dramatic disappearances are not always natural? Science fiction has been whispering this possibility for decades. From Dyson spheres to starlifting authors and futurists have speculated about the power a civilization might wield once it has mastered the engineering of entire solar systems. A Type 2 civilization on the Kardashev scale, capable of harnessing the total energy output of a star, would not need to travel between worlds for resources. It could bend the very heart of its home system to its will. and to do that it might need to enclose or alter the star itself. From our vantage point, light years away, the result would be indistinguishable from a star simply going dark. The most famous of these concepts is the Dyson sphere, named after physicist Freeman Dyson, who in 1960 proposed that advanced civilizations might build vast swarms of structures around their stars to capture their energy. Contrary to the popular image of a solid shell, Dyson's original idea envisioned a swarm of individual collectors, satellites, mirrors, and habitats orbiting in a dense cloud. Such a structure would block much of the star's light from escaping, particularly in visible wavelengths. An observer far away might see the star dim or vanish, entirely replaced by the faint glow of waste heat radiating in the infrared. This is where the ghost star becomes tantalizing. If in the centuries between its appearance in ancient records and our present-day surveys such a civilization had built its energy-harvesting megastructure, the change would be exactly what we see: light gone, the star itself invisible in the wavelengths our ancestors used to see it. We might not have noticed the infrared signature, or perhaps the technology is far beyond even our ability to detect. For us, the effect would be the same as a star that had died. Some scientists have dared to look for signs of this. Projects like the Glimpsing Heat from Alien Technology's GHAT survey have combed through data from telescopes that can detect infrared radiation hunting for stars that appear unusually dim in visible light but bright in the bruma. Infrared. Most candidates turn out to have natural explanations: dust clouds, stellar variability, or data errors. But the search is ongoing because the idea is too compelling to abandon. If we found such a case, it would be among the most profound discoveries in human history, the first evidence that we are not alone. The challenge, of course, is that the natural universe already provides many ways to make a star disappear. Thick clouds of interstellar dust can hide a star from our view, making it seem to vanish even though it still shines. Stars can also be obscured by their own debris. Planetary collisions, massive eruptions, or layers of expelled gas can block their light for decades or centuries. And yet, when we look at the ghost star through this lens, the disappearance feels different. The absence is total, with no detectable afterglow, no evidence of natural obscuration. It is as if someone drew the star's light inward, keeping every photon for themselves. Here imagination brushes uncomfortably close to possibility. Consider what it would mean for a civilization to have that kind of power. They would be so far beyond us technologically that our existence might not even register to them. They could be building Dyson spheres for reasons we cannot fathom, not just for energy, but for art, religion, or motives that have no human analogue. They might have no desire to signal their presence, no interest in the kind of interstellar communication our species dreams about. The disappearance of the star might not be a message at all, just a side effect of their own survival or ambition. There is also the darker side of this speculation. Some have wondered if a star could be deliberately extinguished as a form of cosmic warfare. The energy output of a star is the lifeblood of any planetary system. Removing it would render planets uninhabitable in a matter of days or years. If advanced civilizations have rivals, and if their conflicts extend across the gulfs of space, perhaps the ghost star is not a construction project, but a casualty. In that case, what we see is the afterimage of a war fought so far above our understanding that we can only register its consequences. Skeptics point out that this is all speculation piled on top of an unsolved mystery, and they are right. We have no proof, no direct evidence, nothing to pin this on anything other than the natural chaos of the cosmos. And yet the very act of imagining such scenarios has value. It reminds us that our understanding of the universe is still young, that there may be phenomena we have yet to even name. The ghost star is not proof of extraterrestrials, but it is a reason to keep looking, to keep asking whether we might one day find a disappearance we cannot explain in any other way. For ancient observers, the idea that a star could be dimmed or stolen by intelligent beings might have been a matter of myth or religion. In many cultures, stars were thought to be the campfires of gods, or the lanterns of spirits. A vanishing could mean the death of a deity or the end of an age. We, with our telescopes and physics, have replaced those myths with different stories, but the feeling they evoke is not so different. Both then and now, a missing star speaks to the limits of our power, the realization that something vast and unreachable can change without our consent or even our awareness. If the ghost star was taken by a civilization, it is possible they never knew we were watching. Across thousands of light years, our world would be a pale, undetectable dot, irrelevant to their work. Yet here we are, building theories, weaving speculation, and wondering if somewhere out there someone once looked back at us and thought the same. And perhaps this is why the idea endures. It is not just about the technology or the possibility of alien life. It is about the feeling of being part of a larger, stranger story, one in which our little corner of the galaxy is not the whole stage. A star vanishes, and we are left to guess whether it died in the silence of physics or was claimed by the will of beings whose existence we have yet to confirm. Either way, the disappearance of the ghost star becomes a reminder that the universe is not static. It is alive with changes, some natural, some perhaps deliberate, all unfolding on scales we can barely comprehend. If this possibility feels unsettling, that is because it should. To accept it means admitting that our species may not be the only, or even the most powerful storyteller in the night sky. It means that some stars may not simply fade but be taken, and it leaves us with one last question. The one that lingers long after the maps have been drawn and the telescopes have gone dark. When we look at the ghost star's empty place, are we seeing the end of a natural life or the handiwork? Part of minds we have yet to meet. Astronomy at its core is the science of looking. We point our telescopes into the night, collect the light that has traveled across unimaginable distances, and try to piece together the story it carries. Most of the time, the process is one of accumulation. More light, more data, more points plotted on our charts. But sometimes the story is told not by what we see, but by what is missing. In the vast ledger of the cosmos, absence can be as revealing as presence, and sometimes infinitely more unsettling. To an astronomer, a star's disappearance is not just an emotional shock. It is a rupture in the continuity of the universe as we think we know it. The night sky is, in human terms, dependable. Constellations remain steady enough for sailors to navigate by them. Patterns endure for centuries. When an object vanishes from a location where it has been recorded for generations, it is not a trivial matter. It is an alarm bell, a declaration that something extraordinary has happened, whether through the slow grind of stellar evolution or through some sudden dramatic event. The idea of absence as evidence is not unique to astronomy. Archaeologists can read the outline of a long-vanished building from the way the soil settles differently where its walls once stood. Historians can infer the existence of a missing letter from the way a conversation in surviving documents suddenly changes tone. Likewise, in the sky, the missing star becomes a shape cut out of the fabric of the universe. You can measure it, describe it, and analyze it, even though you can no longer touch or see the thing itself. The coordinates remain like a blank space on a map, daring you to explain it. When early astronomers recorded the position of a star, they were in a sense sealing it into history. That mark on a parchment, that scratch on a brass astrolabe, was a statement, here light exists. Centuries later, when you point a telescope at the same spot and find only darkness, the contradiction between those two statements is powerful. It forces a confrontation with the limitations of our knowledge. Either the early recorders were wrong, which demands we reconsider their entire body of work, or something happened in the intervening centuries to erase the star from our sky. The emotional impact of such an absence is difficult to overstate. Imagine reading an old explorer's journal that describes a towering mountain at a certain location, then traveling there today to find a flat horizon. You would not only question the accuracy of the record, you would wonder about the forces required to remove something so seemingly permanent. That is the sensation astronomers face when they encounter the ghost star. The page is missing, the ink has faded, the The mountain is gone, but the memory remains in the archives, daring us to explain the loss. Modern science gives us tools our ancestors could never have imagined, but the principle is the same. A missing object is data. In fact, in the language of astronomy, this is called a null detection, an observation of nothing. Paradoxically, null detections can be among the most valuable results in science. They constrain the possible explanations. If you expect to see a star of a certain brightness at a certain place and you don't, you have just learned something critical about the universe. It may be telling you about dust clouds, about catastrophic stellar events, or perhaps about phenomena we do not yet understand. The challenge is that absence is inherently harder to study than presence. When a star explodes, it sends out light neutrinos and gravitational waves. We can catch those signals and learn from them. But when something simply stops shining, there may be no aftershock, no lingering fingerprint. The trail goes cold in an instant. What you are left with is not the debris of an event, but the silence after it. Studying that silence requires patience, creativity, and often an acceptance that the answer might remain out of reach. This is why the ghost star is so haunting. It is not like a supernova where the death of the star announces itself with blinding light. Nor is it like a variable star where predictable patterns of dimming and brightening give clues to internal processes. The ghost star is a clean erasure. One moment it is there a fixed point in the grand pattern of the night sky, and the next it is gone. The coordinates now point to nothing but the faint, cold glow of distant galaxies behind it. Some researchers have compared this kind of disappearance to tearing a page from the book of the cosmos. The narrative still flows around it, but there is an uncomfortable gap. You can guess what might have been written there based on the surrounding pages, but you can never be entirely sure. And unlike a book, you cannot simply track down another copy. The universe offers no reprints. The lost page is lost forever, unless you can reconstruct it from the traces it left in other parts of the story. There is also a philosophical dimension to the evidence of absence. We are trained to trust what we can measure, and in astronomy that has historically meant light. Stars are defined by their light. Without it, they are invisible to us. When the light is gone, we are left confronting the uncomfortable truth that our knowledge of the universe is filtered through the narrow slice of reality our senses and our instruments can access. A vanished star might still exist in some form, but if we cannot detect it, we are blind to its fate. In this sense, the ghost star is a reminder of the fragility of our cosmic perspective. We think of the night sky as eternal, but it is not. Stars are born, live and die, on timescales that, while vast to us, are fleeting in cosmic terms. 1,000 years is nothing to a star, unless something extraordinary happens. The fact that we may have witnessed such a rare and rapid change in the heavens is both thrilling and unsettling. And then there is the personal element, the way absence resonates in the human imagination. If you have ever returned to a childhood home only to find it demolished or revisited, a favorite place only to see it changed beyond recognition, you know the shock of loss. Multiply that by the scale of the universe, and you approach the feeling of looking at the ghost star's coordinates today. It is not just the loss of a light in the sky, it is the loss of a reference point, a thread in the tapestry of our shared celestial heritage. We may never know what happened to the ghost star. It could be the result of natural forces beyond our current understanding, or it could be something entirely unexpected, the kind of event that forces us to rewrite our textbooks. Until then, the absence itself remains a kind of evidence, one that demands attention. It tells us that change is possible even in the most seemingly stable corners of the cosmos, and that what we take for granted today might be gone tomorrow. Perhaps the most unsettling part is this. When you stand beneath the night sky and look toward the spot where the ghost star once shone, you are looking at nothing, and that nothing is not empty. It is filled with questions, with possibilities, with the weight of an unanswered story. The blank space is a presence in its own right, a silent marker that something happened here. And in astronomy, as in life, sometimes the silence is the loudest part of the song. Tracing a star through time is a peculiar kind of detective work, one in which the trail is not a path worn into the ground, but a scatter of pinpricks across parchment glass and eventually digital sensors. Imagine opening a star atlas from the late 1700s, its pages browned at the edges, the ink faded, but still holding the shape of constellations as someone once saw them. Somewhere among those dots is the mark for a particular star, unremarkable in its brightness perhaps, but fixed enough to be charted. The astronomer who placed it there likely did so with the quiet confidence that the star would outlive both of you. And yet here you are centuries later, standing at the same coordinates with the most advanced telescopes ever built, and there is nothing there. This is not a common occurrence, which is exactly why it stirs the imagination so fiercely. The night sky, while not truly static changes on timescales, so vast that human lifetimes usually witness no more than the tiniest flickers of variation. For a star to be here in one generation's records and gone in another's is like finding an ancient city marked on an explorer's map, only to discover an empty desert in its place. The absence forces you to decide whether to trust the mapmaker or the desert, the historical record or the current reality. The process of verifying such a disappearance is meticulous, bordering on obsessive. You do not simply look once and declare the star gone. You check and recheck the coordinates, consult multiple atlases from different eras, account for precession, the slow wobble of Earth's axis that shifts the apparent position of stars over centuries, and consider whether the object might have been something transient all along, like a nova or a variable star in a particularly bright phase. In effect, you are peering backward through time, aligning the clockwork of celestial mechanics with the imperfect instruments and techniques of the past. 18th century star charts, for all their artistry, were products of human eyes and human hands. Even the best observers made errors in measurement, sometimes mistaking a planet for a star, or recording the same object twice under slightly different positions. These were not mistakes born of carelessness, but of the technological limits of the time. To account for this, modern astronomers cross-reference historical maps with photographs taken during the first era of astrophotography in the 19th century. Glass plates kept in dusty archives provide a bridge between hand-drawn charts and the CCD images of today. If a star appears in the early photographs and then vanishes in later ones, the case for its disappearance strengthens. Sometimes, however, the trail gets stranger. The missing star will not be an isolated anomaly, but part of a subtle pattern. In certain regions of the sky, the losses seem to cluster as though an entire section of the stellar tapestry is thinning. These are not sweeping changes obvious to the naked eye, but faint statistical hints that only emerge when comparing vast catalogues across centuries. It is almost as if the universe is rearranging itself so slowly and quietly that we only notice when we pause long enough to compare then and now. If this is true, if there is a pattern, then we are faced with a question: is the change a result of natural astrophysical processes we simply have not recognized yet, or is it a side effect of our perspective, our instruments, our interpretation? The temptation is to leap toward the exotic clusters of stars, collapsing into black holes en masse. Cosmic structures shifting on timescales we thought impossible, or even intentional manipulation by advanced civilizations. But the discipline of science requires a slower path. Patterns can mislead, especially when the data is incomplete or the archives are inconsistent. One of the challenges is that we can never step fully outside the problem. We are always observing from Earth, always bound by the limits of our own sky and our own history of observation. Even the best modern sky surveys, with their millions of meticulously catalogued objects, will one day become the old maps of future astronomers. If they find discrepancies between our data and theirs, they will face the same questions we do now. What was real, and what was merely a reflection of our imperfect sight? Still, the possibility of a genuine slow-motion transformation is tantalizing. Stars do not simply blink in and out of existence, not under ordinary circumstances. They evolve, swell, burn out, collapse. But if you were patient enough, if you could watch for tens of thousands or millions of years, you would see constellations deform, galaxies drift, and whole regions of the sky fade or flare. We cannot watch on that scale, but perhaps we are catching fragments of it, sped up in rare cases by processes we do not yet understand. The pattern, if it exists, could be a clue to something profound, a window into the dynamics of stellar death or birth on scales just barely brushing against human perception. Imagine a slow tide, not of water, but of light creeping across the sky over centuries, erasing some stars while revealing others. We might be living in the first era of human history, capable of detecting such a tide simply because we have now accumulated enough precise long-term records to notice. And there is a strange intimacy to this work. To trace a missing star is to share a project with someone long dead. You are not just using their measurements, you are peering through their eyes, trying to see the sky as they saw it. You might find notes in the margins of an old chart, a tiny cross, a smudge of ink where they paused, perhaps a correction where they doubted themselves. These artifacts are as much a part of the investigation as the light we collect today. They remind us that astronomy is not only the study of the universe, but the study of our relationship with it over time. In the end, whether the pattern proves real or illusory, the act of tracing a star across centuries reshapes how we see the cosmos. It forces us to think in spans that outstrip a human life, to treat archives and instruments as time machines, and to accept that even the firmest truths may be provisional. The ghost star is not just a mystery frozen in the past. It is an invitation to keep looking, to keep comparing, to keep wondering whether the changes we detect are whispers of something vast and hidden, still unfolding in the dark. Because perhaps the most important lesson in all of this is that the sky you see tonight is already a version of the sky that will not exist forever. The constellations are only temporarily fixed, the bright points only temporarily bright. Somewhere out there, other stars may already be on their way to becoming ghosts. Their light still traveling toward us across centuries, even as their place in the present universe falls into shadow. And when they do vanish from our charts, someone in the future may pick up the trail just as we are doing now, chasing a dot across time, guided only by the fragile promise of an old map. The idea that a vanished star might not have died at all but simply slipped away into another universe sounds like pure science fiction at first. Yet in the deeper corners of theoretical physics, it is a possibility that some researchers are willing to entertain. Our universe, according to several interpretations of quantum mechanics and cosmology, might not be the only one. Instead, it could be just one bubble in a vast cosmic foam, each bubble containing its own laws of physics, its own galaxies, its own histories. These universes might be forever sealed off from one another, but perhaps not entirely. In certain models, the boundaries between universes are not absolute. They might ripple, fluctuate, or even briefly overlap in ways we cannot yet predict. During such a fleeting alignment, light from a star in another universe could seep into ours, appearing in our sky as if it belonged here. We would have no way of knowing the difference. To our eyes, it would be just another point of light among billions fixed in place as the Earth spun beneath it. But when the alignment faded, when the invisible geometries of higher dimensions shifted, the connection would snap. The star would vanish, not because it had exploded or dimmed, but because it was no longer in our universe to see. This perspective radically reframes the ghost star problem. Instead of treating disappearance as an endpoint, the final act of a dying star, it becomes a side effect of cosmic geography, a trick of the boundary between worlds. The vanishing is not a death, but a departure. In that sense, the ghost star would still exist, shining just as brightly, only in a realm forever beyond our reach. Of course, this raises questions that border on the philosophical. If you see light from a star that does not exist in your universe, have you truly seen it? Is it part of your reality, or merely a reflection from somewhere else? The photons that entered your telescope are undeniably here, interacting with your instruments recorded in your data. Yet their origin lies outside the framework of space-time as you know it. It is as if a traveler appeared at your door, shared a story, and then step through a hidden passageway into a country you cannot visit. You can remember the meeting, even prove it happened, but you cannot go where they went. There is also the matter of time. If parallel universes exist, they might not run in perfect synchrony. A star we glimpse from another cosmos could be older or younger relative to our own universe's clock. We might be seeing its distant past or its far future. In some strange sense, ghost stars could be messages from other timelines carried not by deliberate communication, but by the raw accident of cosmic alignment. And if such alignments can happen once, they might happen again, not necessarily in the same place, but perhaps somewhere else in our sky. An untraceable pulse of connection between worlds. The physics behind such scenarios is daunting, grounded in higher dimensional theories like string theory or the multiverse hypotheses of eternal inflation. These are ideas that for now cannot be directly tested. Even the most advanced telescopes and instruments cannot reach across universes, but they can search for patterns for clusters of unexplained appearances and disappearances that defy conventional astrophysical models. If ghost stars tend to appear in certain regions of the sky more often than random chance would allow, or if their distribution hints at some underlying geometry, we might have the first indirect hints of cross-universal interference. Skeptics point out that extraordinary claims require extraordinary evidence, and right now the evidence for parallel universes is mostly circumstantial, rooted in mathematical consistency rather than observational proof. The simplest explanation for most missing stars remains mundane observational errors, misidentifications, or rare but natural astrophysical events like failed supernovae. But simplicity does not always mean truth, and the history of science is full of cases where the stranger explanation turned out to be correct. There is also the emotional allure of the multiverse. For those who have spent nights poring over old star charts, measuring the emptiness where a light once shone, it is strangely comforting to think that the star might still exist somewhere untouched, carrying on in a place just beyond the proms. Weil. It reframes loss into separation, the way an old friend's departure is softened by knowing they are still alive somewhere else living their story. The tragedy of a vanished star becomes instead a kind of cosmic romance. Still, the challenge remains, how do you prove such a thing? If the universes are truly separate, direct evidence might be forever out of reach. The most we can hope for is to catch these brief flickers, to record them carefully, and to compare them with every other unexplained light in the sky. In doing so, we might one day assemble a map not just of our universe, but of its intersections, rare windows where the impossible becomes momentarily visible. Perhaps in the far future, our descendants will develop tools that can reach across those boundaries, instruments that can trace the faint gravitational or quantum signatures of another world brushing against ours. They might then confirm what we can only speculate, that the night sky is not merely the dome of our universe, but a patchwork of overlapping realities, each casting shadows and reflections into the others. Until then, the ghost star remains a tantalizing mystery balanced between science and speculation. It challenges us to think beyond the familiar, to imagine that our cosmos might not be the whole story, and that what we see or fail to see could be shaped by events happening in worlds we will never touch. The absence in our sky could in fact be the presence of something far greater just beyond the horizon of our reality. And so the next time you look up and see the constellations spread across the dark, remember this: some of those lights might be ours, bound to the same universe that cradles you, while others could be fleeting visitors slipping in from realms unknown, staying only long enough to be noticed before retreating back into the infinite elsewhere. In that possibility lies both wonder and humility, the reminder that the cosmos is always larger, stranger, and more intricate than the small corner we can claim as home. The night sky feels eternal and unchanging, a vault of precise pinpricks that have been there for millennia. But what if one of those bright, steady points is not a star at all? What if it is nothing more than a mirage, a fleeting trick played by the most deceptive of mediums, light? The human eye is a master at interpreting patterns, yet it is also easily fooled. When we look up, we are not seeing the universe directly. We are peering at it through the thick, restless lens of Earth's atmosphere, a medium that bends, scatters, and distorts the light arriving from the depths of space. Every photon that reaches us has traveled an unimaginable distance, passing through the vacuum of interstellar space, unimpeded only to have its final moments scrambled by a swirling ocean of air. The atmosphere is never still. It is a churning mix of temperature layers, moving winds, and shifting densities, each of which can alter the path of incoming light. This bending of light refraction is what makes the sun appear flattened and distorted when it hovers just above the horizon, and it can also make stars appear higher in the sky than they really are. In extreme cases, atmospheric refraction can conjure something from nothing, producing a bright star-like point where no star exists. To the naked eye, such an illusion can look convincing. It can linger for minutes or even hours, especially if the air layers are stable enough to maintain the precise alignment needed to guide stray light to your eyes. But refraction is only one trick in nature's repertoire. Reflection and scattering can also create false lights. High-altitude ice crystals can act like tiny mirrors, catching and redirecting the glow of the moon planets or even distant cities. When those reflections happen in narrow, concentrated beams, they can appear as isolated points of light far above the ground. Sometimes these illusions are stationary, and sometimes they drift or shimmer, making them look uncannily like real celestial objects. Without the context of a telescope or careful triangulation, it is nearly impossible to tell the difference. Light can also be bent and redirected by temperature inversions, layers of warm air trapped above cooler air. These inversions act like massive invisible lenses, bending light over the horizon and delivering images from far away. On rare nights, this can cause a phenomenon known as a superior mirage, in which objects that are normally hidden appear elevated and ghostly. Ships seem to float in the sky, distant coastlines hover above the sea. And yes, false stars can appear to shine where the sky should be empty. These mirages can be stable enough that if recorded on an old star chart, they might fool future astronomers into believing a star had once existed there. Then there is the issue of interference. In the upper atmosphere, thin layers of varying temperature and density can create diffraction effects, patterns of constructive and destructive interference in the light waves themselves. Under certain conditions, this can enhance a faint source until it becomes visible to the human eye, or it can even create the impression of a point source where there is none. Such effects are fleeting, but human memory and historical records are not perfect. If a sailor in the 18th century saw such a light and marked it down, that single moment could seed centuries of speculation. Even telescopes, those instruments we trust to bypass our flawed senses, are not immune to deception. In earlier centuries, lenses and mirrors were imperfect, prone to scattering light internally or producing reflections from bright sources just outside the field of view. A bright planet or star could bounce within the optics and produce a secondary image faint but distinct in another part of the sky. Astronomers unfamiliar with these quirks could catalogue such a phantom as a real object, unknowingly planting a ghost in the celestial record. And yet there is something tantalizing about the idea that some ghost stars might simply be illusions. It reminds us that the universe we think we know is filtered through layers of complexity, not only the physical barriers of distance and time, but also the distortions of our own planet and instruments. An atmospheric mirage is a reminder that even the most seemingly direct observation is still a negotiation between reality and perception. The star might never have existed, but the experience of seeing it was real enough to inspire wonder, curiosity, and perhaps even a bit of misplaced certainty. This uncertainty carries a certain humility. We like to think of astronomy as a precise science, and in many ways it is. We can measure the wobble of distant planets, detect the faint afterglow of the Big Bang, and track the dance of galaxies billions of light years away. But every observation must still pass through fallible human judgment, and sometimes through an atmosphere that is anything but cooperative. A ghost star that turns out to be nothing more than a mirage is not a failure of science. It is a testament to the need for rigor, skepticism, and verification. Consider, for example, the many cases of new stars reported in history that later turned out to be misidentified, planets' high-altitude balloons, or even reflections from the surface of water or ice. Each of these misidentifications was genuine in the sense that someone truly saw something, but what they saw was not what they thought. In the case of atmospheric illusions, the boundary between real and unreal blurs in fascinating ways. The photons reaching your eye are real, but their apparent source is a fiction assembled by refraction, reflection, and scattering. Perhaps that is why the idea of ghost stars as illusions is both satisfying and disappointing. It offers a grounded physical explanation that fits neatly within our understanding of optics and atmospheric science, but it also strips away some of the mystery. It turns the romantic notion of a star vanishing into nothingness, into something more mundane, a ripple in the air, a twist in the path of light, a momentary trick. And yet, even in this demystified form, there is beauty. The idea that our atmosphere, the same blanket of air that carries the scent of rain and the warmth of summer, can also conjure phantom lights from thin air, is a reminder of how dynamic and strange our world is. In the end, whether a ghost star is a collapsed sun, a visitor from another universe, or simply an illusion born of shimmering air, its presence in our records tells us something important. It tells us that humans have always been watching the sky, searching for meaning in the lights above, and sometimes finding it in places where there is nothing at all. The vanishing of a star may be a cosmic event or a local trick of the atmosphere, but in both cases it challenges our certainty, pushing us to look again, to measure carefully, and to remember that even the most familiar truths can be shaped by the medium through which we see them. And so the next time you spot a new light in the night sky, pause for a moment before claiming discovery. It might be a supernova, a planet, or a spacecraft, but it could also be nothing more than the atmosphere itself playing with the starlight, crafting a fleeting illusion that will fade before you have the chance to prove it was ever there at all. There is something deep in the human mind, an ancient itch that refuses to be ignored. You can see it in the way early explorers set sail into uncharted waters, risking storms, starvation, and mutiny, just to see what lay beyond the horizon. You can see it in the quiet obsession of an astronomer hunched over a telescope at 3 a.m, chasing the faint glimmer of a star no one else has noticed. We are drawn to gaps in our knowledge the way a tongue is drawn to the gap left by a missing tooth. The absence itself becomes a presence nagging at us, demanding to be filled. It doesn't matter whether the mystery is grand or trivial. A missing island on an old maritime map can be just as captivating as the disappearance of a star catalogued 2 centuries ago. Sailors once scoured vast swaths of ocean looking for phantom lands, convinced that they must exist because someone had seen them before. They rarely stopped to consider that perhaps the original sighting was an illusion, a trick of fog and light, or a simple error. The fact that the map promised something was enough. The void between belief and evidence is where human imagination thrives. Part of this comes from a primal survival instinct. For most of human history, knowing what was beyond the ridge or across the river was not just curiosity, it was safety. A predator could be waiting, an enemy could be camped there, or perhaps there was food shelter or fresh water. Those who ignored the unknown often didn't survive long enough to pass on their genes. Our brains evolved to notice anomalies, to focus on changes in our environment, and to treat gaps in information as urgent problems that must be solved. In the modern age, the stakes are rarely so immediate, yet the instinct remains. When we find a mystery, it refuses to leave us alone. The missing star becomes more than an astronomical anomaly. It becomes a challenge. We start imagining scenarios. Maybe it collapsed into a black hole, maybe it's shrouded in a thick cloud of dust, maybe it was never there to begin with. Even the most skeptical scientist is not immune to the pull. The mystery demands an answer, and the absence of one becomes almost unbearable. This is why ghost stars and vanished islands and lost civilizations fascinate us so deeply. They sit at the intersection of 2 powerful human drives: the need to understand and the fear of what we don't. There is a peculiar discomfort in admitting that something is simply unknowable. We like to think that given enough time and enough data, we can solve anything. The idea that some questions might remain forever unanswered feels like a personal affront, as if the universe is withholding a truth that rightfully belongs to us. There is also an aesthetic dimension to it. A complete story can be satisfying, but an incomplete one can be haunting. The blank spaces in an old map, the starless coordinates in a celestial chart, these are places where the imagination runs free. A solved mystery has boundaries, an unsolved one has infinite possibilities. Perhaps this is why fiction so often begins with a mystery rather than an explanation. The unknown is a fertile ground for storytelling, and in chasing the answer, we create narratives that often matter more than the truth itself. The pursuit of mysteries can also be intoxicating because it gives us purpose. A scientist devotes decades to tracking down a single anomaly, not just to prove something, but because the act of pursuit is deeply rewarding. To investigate a mystery is to live in a constant state of anticipation, balanced between hope and frustration. Each new clue feels like progress, even if it only eliminates possibilities rather than providing a definitive answer. In this way, the mystery becomes part of one's identity. It stops being just a question about the world and becomes a personal quest. Of course, not all mysteries can be solved and not all should be. Some are better left as they are because the truth might be mundane compared to the dream. Imagine devoting your life to searching for a lost city, only to discover that it was nothing more than a mistranslation in a centuries-old text. The rational mind might be satisfied, but the romantic in you would mourn the loss. The beauty of the unknown lies partly in its ability to remain just out of reach forever, a space for speculation, and yet we can't help ourselves. The very act of saying we may never know is like dangling a carrot in front of our own minds. We start turning the problem over and over, testing angles, probing weak points, looking for a crack through which we might force an answer. It's not just about knowledge, it's about control. A mystery is a reminder that the world and the universe is not entirely in our grasp. By solving it, we reclaim a little bit of that control, or at least the illusion of it. In the case of ghost stars, the allure is amplified by the scale. Here is something happening not in a locked room or a faraway jungle, but in the vast theater of the cosmos. A star is a symbol of permanence. It burns for millions or billions of years, outlasting empires, civilizations, and species. To see one disappear is to confront the fragility of even the most seemingly eternal things. If a star can vanish without a trace, what else can? What else already has? This is why, even knowing that some ghost stars might turn out to be nothing more than cataloguing errors or tricks of light, astronomers still search for them. Each one is a puzzle, and puzzles beg to be solved. Some may lead nowhere, others may lead to profound discoveries, new astrophysical phenomena, unseen objects, or even evidence of civilizations beyond our own. The uncertainty is part of the thrill. The possibility of being wrong is outweighed by the possibility of uncovering something extraordinary. Perhaps that is the real heart of it. The chase matters as much as, if not more, than the catch. We are creatures built to seek, to question, to follow the trail of clues, even when they seem to vanish into thin air. The missing island, the vanished star, the unexplained signal, these are invitations. They whisper that the world is not fully mapped, that the universe still has secrets, that there are still dragons at the edge of the chart. And once we hear that whisper, we cannot help but follow it. In the end, the mystery of the ghost star is not just about astrophysics. It is about us. It reflects the restless, stubborn, endlessly curious nature of the human mind. Even if the answer turns out to be simple, even if it turns out that the star was never there at all, the journey toward that answer will have been worth it. Because the moment we stop chasing mysteries is the moment we stop moving forward. And deep down we know that the silence of an unsolved mystery is far less frightening than the silence that would come if we ever stopped asking questions at all. Imagine looking at the night sky, memorizing the precise coordinates of a bright, familiar star, and then one evening finding nothing there but darkness. At first you might suspect your eyes, then your telescope, Then the weather, the dust, the atmosphere. But suppose all those things check out and the star is still gone. The unsettling possibility begins to creep in. Maybe the star didn't die, didn't fade, didn't explode. Maybe it simply left. Theoretical physics, as wild as it can sometimes sound, has given us frameworks that allow for such possibilities. Among them is the concept of a wormhole, a bridge or tunnel between two distant points in space-time. In popular imagination, wormholes are portals for spaceships, shortcuts to other galaxies or pathways to alternate universes. But the equations don't care whether the traveler is a starship or a star itself. Under extreme conditions, it's not entirely beyond reason to think that a massive celestial body could fall into such a bridge and emerge somewhere else entirely. For a star to move in such a way would be a cosmic event unlike anything we've ever observed. Most of the universe's large-scale processes happen slowly, glacially, on timescales that make human history seem like a flicker. Stars are born, live and die over millions or billions of years. Their change is gradual enough that they are invisible to the casual observer. But a wormhole, that would be sudden. One moment the star is there, the next moment it's simply not. To us it would look like vanishing, a disappearance, so abrupt it would defy the usual astrophysical playbook. If such an event happened, what would it mean? Somewhere else in the cosmos, perhaps in a region we've never charted, that same star could blaze into the sky of another world. To any observers there, it might appear suddenly, just as it vanished from our sight, a new, unexpected point of light against their night. Imagine the confusion, the debates, the awe. If they are an intelligent civilization, perhaps they would make the same mistake. We might assuming the star had been born there, rather than having traveled across space-time to arrive. Of course, there are questions. How would a wormhole form large and stable enough to accommodate a star? Wormholes, if they exist at all, are predicted to be incredibly unstable, prone to collapsing in the tiniest fraction of a second. And even if one remained open, the tidal forces around it could be catastrophic, shredding anything that approached. Yet some solutions to Einstein's equations suggest that under the right conditions, perhaps with the presence of exotic matter that has negative energy density, a wormhole could be kept stable. We don't have such matter in our laboratories, but in the vast, strange corners of the cosmos, who's to say it doesn't exist? This line of thinking moves us into territory where physics and imagination mingle freely. Science fiction has played with this notion for decades. Stars transported across the galaxy, suns stolen from one system to light another, whole constellations rearranged like chess pieces on the board of the universe. The difference is that while fiction tends to bend the rules of physics to make these stories possible, theoretical physics keeps the door just barely cracked open, whispering. It's unlikely, but not impossible. For astronomers on Earth, the challenge would be to detect any trace of such a journey. If a star were truly pulled through a wormhole, there might be gravitational ripples, faint tremors in space-time itself, radiating outward from the event. These are the kinds of disturbances we can now detect with instruments like LIGO and Virgo, though they are most often caused by collisions of black holes or neutron stars. A wormhole transit might leave a signature unlike anything we've recorded before. The problem is we wouldn't know what to look for until we saw it. The philosophical implications are as vast as the astrophysical ones. If stars can move across the universe through hidden pathways, the sky we see might be less fixed than we think. Constellations could change not just because of the slow drift of stellar motion, but because whole stars take shortcuts through cosmic tunnels. The patterns our ancestors traced in the heavens might shift suddenly, even within a single human lifetime, leaving future generations with a different sky entirely. And what if this isn't rare? What if stars slipping through such doors happens more often than we realize, but we lack the tools or timescale to notice? Over billions of years, the universe could be quietly shuffling its pieces, stars migrating from one corner to another, some vanishing from our charts, while others appear without explanation. The night sky we inherit might be a patchwork quilt stitched together from stars born in places far removed from our own galactic neighborhood. In that light, a ghost star, one that disappears with no trace of death, could be a traveler, not a casualty. It would mean that disappearance is not always an ending. Sometimes it's a relocation. Somewhere on some other world, perhaps beneath an alien ocean, or in the thin air of a frozen plateau, another set of eyes might be marveling at the sudden appearance of what they think is their own new star. They might be writing their own myths about it or building their own telescopes to study it, never realizing that they're looking at the same sun we once did. This idea also forces us to reconsider the meaning of distance. If wormholes or similar shortcuts exist, the traditional concept of far away starts to blur. A star on the other side of the galaxy could be, in a sense, just a step away if the right doorway opens. Likewise, something unimaginably distant could suddenly appear close, rewriting our maps in an instant. For now, we have no direct evidence of such doorways. The ghost stars we've catalogued could be explained by other means: measurement errors, dust clouds, collapsed remnants that emit no light. But the wormhole hypothesis lingers because it touches something profound. It suggests that the universe is not just a static backdrop but a dynamic and possibly interconnected web full of unseen routes and hidden destinations. If we ever did confirm that a star had traveled this way, it would be more than a scientific milestone. It would be a reminder that the cosmos is stranger than we allow ourselves to believe, that what vanishes from our sight might not be gone only elsewhere, that the dark patch where we once saw light could be the edge of a doorway, and beyond it a sky we have never seen waiting for someone somewhere to look up and wonder where their new star came from. Even the most powerful eyes we have ever turned toward the sky are not all-seeing. The James Webb Space Telescope, with its golden mirror array and instruments tuned to peer through cosmic dust, can reach billions of light-years into the past, glimpsing light that left its source before the Earth even formed. And yet, for all its sophistication, there are places it cannot look and things it cannot see. Every telescope, no matter how advanced, carries blind spots, regions of the spectrum it cannot observe, angles it cannot reach, objects hidden behind veils it cannot penetrate. In the vastness of space, these blind spots are more than a minor inconvenience. They can hide entire stars from us. Imagine a star burning brightly in some distant arm of the galaxy, its light spilling out in all directions, yet on its way toward us, it passes through a dense cloud of interstellar dust. To human eyes, it would vanish. To Webb's infrared sensors, it might be visible if the dust is thin enough. But if the cloud is too thick, too cold, or simply oriented in just the wrong way, the light could be completely smothered before it ever reaches us. From our perspective, it would be as if the star had ceased to exist, though in reality it still burns with undiminished fire. The problem isn't just dust. Every telescope works within a range of wavelengths, slices of the electromagnetic spectrum. Webb specializes in the infrared, which is excellent for peering through certain kinds of obscuring matter, but useless for detecting phenomena that only radiate in, say, the radio spectrum or at extremely high-energy gamma rays. Other telescopes like Hubble or the massive radio dishes of the Very Large Array cover different ranges, but none of them cover it all. And so there are things in the universe that slip between our instruments, not because they are faint, but because they shine in colors we have not learned to see. There is also the matter of perspective. Some regions of the sky are simply harder to observe because of where we are in the galaxy. The Milky Way itself, with its dense central bulge of stars, gas and dust, blocks our view of what lies behind it. We see it as a luminous band, stretching across the night sky, but that brightness is also a curtain concealing whatever lies beyond. If a ghost star happened to be in that hidden territory, we might have no way to spot it, no matter how advanced our telescopes become. Then there are the practical limits of observation time. The James Webb Space Telescope cannot stare at one patch of the sky forever. It must divide its attention, allocating precious hours to different projects, different regions, different teams of scientists. If a star briefly flares, dims, or disappears during the months or years Webb is pointed elsewhere, we may never know it happened. In that sense, our cosmic vision is not only limited by technology, but also by the rhythms of scheduling, the politics of science, and the sheer fact that there is far more sky than there is telescope time. Sometimes the limitations are not in the hardware, but in our interpretation. Telescopes collect photons, streams of light particles that have traveled unimaginable distances, and translate them into data. That data must then be processed, cleaned, and interpreted by humans and computers. In the noise of imperfect measurements, faint signals can be lost or mistaken for errors, or drowned out by the overwhelming glare of brighter objects nearby. A ghost star might leave a whisper in the data, but if we are not listening carefully enough, we might never hear it. This is why astronomers often speak of the universe as if it were an iceberg. The part we can see, the galaxies and stars and nebulae we photograph, is just the tip. Beneath it lies the invisible dark matter, dark energy, faint or hidden stars, objects whose light is absorbed or shifted into ranges we cannot detect. In this view, a disappearing star might not have vanished at all. It might simply have slipped into the vast, unseen portion of the cosmic iceberg beyond the reach of our current senses. The awareness of these blind spots adds a kind of humility to our search for the truth. It reminds us that absence in our data is not always absence in reality. When we fail to see something, we must ask whether it is truly gone or merely hiding in a place we cannot yet look. History has shown us that many empty regions of the sky are only empty because our tools were not sensitive enough to reveal their contents. The first radio telescopes unveiled a universe buzzing with signals invisible to optical instruments. The launch of X-ray observatories revealed violent cosmic processes we had never imagined. Each leap in technology has turned void into abundance. It is entirely possible that future telescopes, tuned to wavelengths we have not yet explored, will bring ghost stars back into view. What now appears as an inexplicable disappearance might someday be explained by a map that sees more colors of the universe than we can currently imagine. Perhaps a century from now, astronomers will look back at our time and shake their heads, wondering how we could have thought the star was gone when it was merely concealed by a veil we didn't know how to lift. Yet even with that hope, the limits of our current instruments force us to live with uncertainty. Somewhere right now there could be hundreds of stars whose light is trying to reach us, only to be scattered, absorbed, or bent away. They are there in reality, but absent from our perception. And in that gap between existence and detection is where mystery thrives. Maybe that's part of why ghost stars hold such power over the imagination. They are a reminder that our understanding of the universe is only as complete as our ability to observe it. Every telescope has its blind spots, and within those blind spots might lie the answers to questions we haven't even thought to ask. Until our tools catch up, we will keep searching, mapping, and dreaming, because sometimes the most profound discoveries are not about what we see, but about what we learn to see next. For centuries, humanity has searched the skies, charting every speck of light we could see, cataloguing its position, brightness, and changes over time. We have maps so detailed that we can pinpoint where a single star once shone hundreds of years ago. We know the coordinates where it appeared, the approximate date when its light first reached us, and in some cases, even the historical context who saw it, how they described it, what instruments they used to record it. Yet despite this wealth of information, we find ourselves standing in the same place. We began staring into the dark, wondering where it went. It is a strange kind of frustration. In most areas of science, the more data you collect, the closer you get to the truth. But with these so-called ghost stars, the opposite seems to be happening. We know enough to confirm that something was there, and yet we have no data that explains where it is now. The coordinates are fixed unchanging in our maps, like an X marking treasure on an old chart. The time of its appearance is locked in historical records, often corroborated by multiple observers. But when we turn our most advanced instruments toward that spot in the sky, we see nothing, just darkness. This tension between knowing and not knowing has always been part of astronomy. After all, when you look into the night sky, you're not seeing things as they are now. You're seeing them as they were sometimes millions or even billions of years ago. The light that reaches your eyes is ancient, its journey interrupted only by the occasional dust cloud or gravitational lens. In a sense, every observation is an act of time travel, and every star we see could already be gone. But with ghost stars, the gap between our records and our current observations feels sharper, almost taunting. We are certain they existed, but their present state is a blank. This uncertainty forces us to confront the limits of what we can claim to know. Science relies on observation and evidence, and when both are partial, the picture that emerges is inevitably incomplete. We can hypothesize that the star collapsed into a black hole, that it exploded in a supernova, too faint or too distant for us to have noticed that it was obscured by a passing cloud of dust, or that it was never a star at all but some transient phenomenon misinterpreted by early astronomers. Each of these theories fits some of the evidence, but none of them fits all of it, and so the case remains open. The most unsettling possibility is that our very framework for understanding what we see is flawed. Perhaps the ghost star was never bound by the rules we think govern stellar behavior. Maybe it was part of a rare class of objects that emit light for a limited time and then fade completely, leaving no trace in any spectrum we can detect. Or maybe, and here the imagination leaps beyond the comfort zone of conventional physics, it interacted with some other cosmic structure, like a wormhole or parallel universe, that caused it to vanish from our reality altogether. Without a clear answer, these ideas remain in the twilight between science and speculation. Part of the reason we can't solve the mystery is that the evidence is locked in time. We cannot go back to the moment when the star was visible to study it with modern tools. The people who saw it centuries ago did the best they could with what they had, and for their time, their observations were remarkably precise. But they did not have the sensitivity of CCD sensors, the reach of orbital telescopes, or the ability to detect wavelengths beyond visible light. What they left us is invaluable, but also limited. We are working with the faint echoes of a moment long gone, trying to reconstruct a reality that may have already transformed. And yet, despite all this, the search continues, because there is something inherently human about not being able to let go of a question once it has taken root. The ghost star becomes more than a point of light, it becomes a puzzle, a test of our ability to push knowledge into the places where answers are reluctant to live. We are drawn to it not just for the hope of solving it, but for what it represents: the edge of the known, the threshold where our maps turn blank. In the end, what we know about the ghost star could fit on a single page. We know where it was when it appeared, and that it is no longer visible. What we don't know could fill libraries: why it vanished, whether it still exists, and what its disappearance tells us about the universe. Between those two realms, the known and the unknown, is where science lives, reaching forward into the dark, with instruments, ideas, and an enduring willingness to be surprised. It is humbling, even a little disorienting, to realize that after hundreds of years of progress, after building machines that can see almost to the beginning of time itself, we can still be stumped by a single missing point of light. But perhaps that is exactly why astronomy remains one of the most profound sciences. It is not just about cataloging what is there, but about accepting and even embracing the things we cannot yet explain. The ghost star may remain lost for decades, or even centuries more. New telescopes will rise, new theories will be tested, and somewhere perhaps far from where we expect, the answer might emerge. Until then, we are left with a paradox: we have searched for centuries, gathered all the facts we can, and yet in the most important sense, we are still standing at the starting line. Every map humanity has ever made, whether of oceans, continents, or the sky itself, has carried a silent flaw. It is already out of date the moment it is finished. The ink may still be wet, the lines precise, the coordinates meticulously plotted, but the world it describes has already changed. Rivers alter their course, coastlines erode, mountains crumble, and in the vastness above, stars shift, flare, fade, and vanish. The universe is not a static canvas. It is more like a living organism, constantly reshaping itself in ways that are both predictable and wildly unexpected. When astronomers chart the heavens, they know they are capturing only a fleeting snapshot, a single frame in an unimaginably long film. That frame might show a star blazing brightly, yet by the time the map is printed, that same star could have dimmed beyond visibility or exploded into a cloud of gas and dust. To the untrained eye, A star chart feels definitive, even eternal, a fixed guide to the eternal dome above. But in truth, it is just a photograph of something in motion. And like any photograph, it tells only part of the story. This is where the ghost star becomes more than a single astronomical mystery. It becomes a metaphor for the unfinished nature of every map we make of the cosmos. Somewhere in an atlas drawn 2 centuries ago, a bright point is marked in ink, confidently labeled and positioned. Today, when we look there, the light is gone. The absence isn't just an error, it's evidence of change, a reminder that the universe doesn't owe us permanence. Maps of Earth have faced the same problem for centuries. Early navigators sometimes marked islands that were never there, perhaps born from misread waves or mirages. Others noted real islands that have since been swallowed by the sea. Similarly, star charts preserve not only the positions of true celestial bodies, but also the ghosts of things that no longer exist in the form we expect. A star on paper can outlive a star in reality by hundreds of years, and it is this lag, this disconnect between representation and reality, that fascinates astronomers. It's easy to imagine the universe as a kind of grand mapmaker, rewriting its own borders, adding and erasing entries without warning. One night a star flares into existence where none had been recorded, and suddenly the map gains a new landmark. Another night a long-known beacon fades away, and the map becomes outdated. Our instruments are like quills trying to keep up with a painter who never stops moving the brush. No matter how fast we work, the picture changes faster still. The truth is, we do not observe the universe as it is. We observe it as it was. Even the closest stars are years away in light travel time. When you look at Alpha Centauri, you are seeing it as it existed more than 4 years ago. For more distant objects, the gap stretches into centuries, millennia, even billions of years. Our maps are therefore not only incomplete, they are full of ghosts by definition. Every chart is a palimpsest, a layered record of different moments in cosmic history superimposed upon each other. The ghost star is a perfect example of this phenomenon. Its recorded light belongs to a past version of the universe. By the time we try to match that light to our current sky, the object itself may have undergone transformations so extreme that it no longer fits the label star at all. In our minds, we draw a straight line between what was and what is, but the cosmos doesn't work that way. Sometimes the line bends or disappears entirely. This makes astronomy a discipline of humility. We are not uncovering a perfectly fixed truth so much as chasing a moving target. Our work is less like cataloguing a museum's static collection and more like trying to describe the behavior of a school of fish from a single photograph. We must learn to accept that change is the rule, not the exception, and that our maps will always be temporary approximations, never final blueprints. And yet this impermanence doesn't make the maps useless. On the contrary, it makes them more valuable. A map is a record of a moment, a preserved memory of how the universe looked at a particular slice of time. Even when wrong by today's standards, it offers a window into both the cosmos and our own history of understanding it. An old star chart with a missing point of light is a reminder of how far we've come and of the questions that remain unanswered. Perhaps the most profound lesson of the ghost star is not about the star at all, but about our relationship with the unknown. It shows us that the universe is not a fixed territory waiting to be neatly mapped, but an ongoing narrative in which pages are constantly being added, rewritten, and sometimes torn out entirely. We are reading that story in real time, aware that entire chapters may be missing, and that some of the characters we meet will vanish before the end. In the end, the phrase "the map is not the territory" applies just as much to the night sky as it does to the earth beneath our feet. A star chart is not the sky, it is a memory of the sky, a record that will inevitably fall out of sync with reality. The ghost star is a reminder that our maps, however precise, will never be complete, and that perhaps they are not meant to be. They are stepping stones, points of reference in a sea of change, and the gaps between them are where discovery lives. We may never find the missing light, and the blank spot on today's charts may remain blank forever. But even so, its presence on old maps serves as a quiet invitation to keep looking, to keep updating, to keep acknowledging that the universe is a work in progress, and so is our understanding of it. The ghost star might be gone from the sky, but in that absence it continues to guide us, marking not the end of the journey but the fact that the journey is far from over. Imagine standing outside on a quiet night, the kind of night where the air feels almost heavy with stillness, and the stars seem close enough to touch. You've grown used to the shape of this sky. You know which points of light belong where. You've even learned to stop looking for the one that used to be there, because for years now, its absence has been as much a part of the night as the presence of the others. The gap has become normal. Then, without warning, something shifts. You glance up, and there it is. A light you once knew by heart, shining exactly where the darkness had claimed it. For a moment you don't move. Your breath catches as your brain races to catch up. Is this real? Is your mind playing tricks? Or has the impossible quietly threaded its way back into the fabric of reality? 100 memories flash through your head. The first time you read about the ghost star, the hours spent staring at an empty patch of sky, the theories and arguments about what could have happened. And now here it is staring back at you like nothing ever happened. You might tell yourself to stay calm, to be rational. The astronomer in you wants to confirm, to double-check, to document. You reach for a telescope or a camera, your fingers suddenly clumsy, your thoughts tangled between awe and disbelief. But the human in you, the part that has long since surrendered to the idea that some mysteries will never be solved, feels something else entirely. A deep, wordless wonder. A quiet, almost childlike joy. What would you believe in that moment? Would you think of redshifts and light travel time, of gravitational anomalies and transient phenomena? Or would you allow yourself just for a second to believe in something that doesn't fit neatly into the equations? The return of a ghost is by definition a contradiction. It shouldn't happen. And yet here it is gleaming against the black. Maybe you would remember that science is not the enemy of wonder. Science thrives on moments like this, moments that defy our current understanding, moments that demand new explanations. If the ghost star came back, it wouldn't be magic instead of science. It would be science in its purest form, the relentless pursuit of truth, the willingness to let go of old models and embrace the unknown. In that sense, the reappearance wouldn't undermine what we know, it would expand it. But still, the emotional part of you might whisper something different. It might whisper that this is personal, that this is the universe tapping you on the shoulder to remind you that not all absences are permanent, that some things return against all odds without warning or reason. And in that private moment between you and the sky, you might feel an intimacy with the cosmos that no textbook can convey. Others would see it too, of course. News would spread. Telescopes around the world would swing toward that point in space, instruments clicking and humming as data poured in. Every astrophysicist who had ever speculated about the ghost star would feel a shiver of vindication or disbelief. Papers would be written, models adjusted, theories reborn, and somewhere perhaps a few quiet voices would still insist on calling it a miracle. The question is not just what the star's return would mean for science, but what it would mean for you. For years you've lived with a gap, a place where something should have been but wasn't. Seeing that gap filled again might stir feelings you didn't realize you were holding on to. Maybe it's hope. Maybe it's the realization that the universe still has surprises left, even for those who think they've seen it all. And yet you might also feel the fragility of the moment. What if it's fleeting? What if, like a shy visitor, the star disappears again tomorrow, leaving you to wonder whether you ever truly saw it? That uncertainty would be maddening. You might spend night after night watching, afraid to blink, terrified that you'll miss its final farewell. The fear of losing it again might make its presence all the more precious. In that way, the ghost star's return would be both a gift and a challenge. A gift because it would reignite curiosity and awe in a world often too busy to look up. A challenge because it would force us to confront the limits of our knowledge yet again. To admit that no matter how far we've come, the universe still knows how to humble us with a single point of light. It's tempting to imagine that you'd have a clean, decisive reaction, that you'd either declare it a scientific event or a mystical one. but reality rarely offers such neat divisions. Most likely you'd stand there for a while looking up, letting both possibilities coexist in your mind. You'd feel the pull of logic and the pull of wonder, and for once you wouldn't feel the need to choose, because maybe the real beauty of the ghost star's return wouldn't be in explaining it, but in experiencing it. In feeling that rare alignment of the outer and inner worlds, where something vast and distant suddenly feels personal and close, where a long absent light reappears not just in the sky but somewhere deep inside you. And if someday it truly does come back, you might remember this moment, the imagining of it, and realize that no amount of preparation could capture the way it would actually feel. You'd look up, see that familiar glow, and think not just about the years it was gone, but about the strange, beautiful fact that it found its way back at all. You'd know in your bones that the universe doesn't give answers easily, but sometimes it gives something better the chance to witness the impossible.